Okay, so I thought I'd go ahead and share this little project. This particular thing's not really going anywhere. There's a thought connected to it that I wanted to share, really. My main little electronics hobby project right now is on hold while I wait for some custom pieces to come from a factory in China. So I was just piddling around with some other stuff while to pass the time, because that's how hobbies go. And I kept seeing these on websites. These little do-it-yourself function generator kits. One of these pictures over here should, should have all this. Oh, this one. So this is the sort of thing where they send you all the components you need, already calculated, figured out, and a nice little PCB that's clearly labeled. So all you have to do is solder the pieces on and it's ready to go. And the point I wanted to make here is that is not what I consider doing it myself. That's just soldering. That's the last step. That negates part of what I consider the fun part of messing around with electronics. Definitely not what I consider doing it myself. So that's why I put this together. This isn't going very far. That's why I'm going ahead and make the video now. It's probably not going any further than this. And so right now the Arduino is just supplying power, and then it's reading those to display the output. Seemed a quick, easy way to display the output. But I kind of wanted to walk through what's going on here. So these are basically just 555 timers. Just the very traditional, standard, good starting point chip. Trusty old 555s. A regular one, and then this one over here is just dual 555s. It's a 555 down each side. So starting over here, this is going to be the square wave. So just hook a 555 up in a stable mode, which connect the discharge and threshold, run that through a resistor to output, and a capacitor back to ground. Gives us a nice little square wave. With that resistor, or the effective resistance on that channel, and the capacitor controlling the frequency of that square wave. Just the basic output on, off, on, off, on, off from a 555 chip. And then that can be modified a little bit. So I'll come up here next. So one thing we can do is go from a nice little square wave and trim off that front edge and back edge. So then instead of the up, on for a split, on for amount of time, then down, then off for amount of time, we kind of trim off those edges and smooth it out so that it slowly goes up, then slowly goes down, and get a triangle wave out of it. And to do that, we have basically the same thing. So output and discharge connected together, discharge and threshold connected together, then those run through a resistor to the output. And then so that is basically, here is where the equivalent to where the output comes out here. But instead of bringing the signal out right there, I run through these other two capacitors. And they do something different. So this one over here, the one furthest from the chip, that takes care of the leading edge. So instead of going straight up and then leveling off, it kind of smooths that out to come up at an angle. And then when the signal goes high, and then when the signal drops low, this second capacitor here smooths out that back edge does kind of the same thing for it coming back down. And that's how we turn a square wave into a triangle wave. And again, adjusting the frequency, the size of this resistor and capacitor, where the discharge and threshold tie into output and run through a capacitor back to ground, or to the desired output. That's what controls the frequency of the wave. And then this stuff just makes these little adjustments afterwards. Another adjustment we can make is over here. So we can take a square wave and I'm going to call it a sine wave. You can see that's the little picture I drew on the flag there. When we look at the output, the state I left it in, it's not that smooth. It probably looks more like a sawtooth, but we'll look at that here in a second. But again, connect the discharge and threshold, run through a resistor to the output. Only this time the output runs solely through an inductor. So after going through the inductor, then it passes in parallel through one capacitor to ground or resistors. These two are in series. It's kind of hard to tell when it's plugged up in the compressed little spot in a breadboard. But through the inductor and then parallel through some resistance or a capacitor to ground. And between those resistors is bringing out the output. And after those resistors is another capacitor back to ground. And kind of what's going on there is similar thing. These two resistors here are kind of like going from the square wave to the triangle wave. It's trimming off those edges. Only going through an inductor, it smooths it out. So it's not just a straight line going up. Instead of just a straight line going up, that inductor kind of smooths it out a lot and smooths it out into a curve. And a similar thing when it drops low, it kind of smooths it out, and then the back EMF drives it, kind of helps smooth it out and drive it down a little faster. So the inductor is very important to get that. Got to have that back EMF to get the smooth curve going. And so here on the Arduino, it's just kind of going in here, supplying power, and then these three lines, if we come over here and look at the code, you can see just have those pins marked. They're all set as input, all set as inputs, and then all this code is doing is just an analog read on each one. So if I come over here and open the serial plotter so we can see the waves, so there's the waves being produced. And if you're not familiar with it, the Arduino reverses this because Arduino by default is set to read inputs. So when it's 0 volts, that's when the analog read is at the highest. So actually up here is 0 volts and down here is 5 volts. And I can reach over here and unplug this to just kind of stop this and point at some spots on the wave. So the square wave's fairly obvious, right? It's backwards, but I'm going to point at it this way because, as you can see, those are symmetric. It flips right over. So it goes up, kind of levels out. There's some little bit of interference from the other ones, but goes up, levels off, drops down. Just a basic square wave going in a pattern. Then the triangle wave going up and down. Then those two capacitors kind of smooth off those edges. And putting this together like this instead of the do-it-yourself kit, I know what each capacitor does. Oh, and by the way, there's you may have noticed there's another capacitor here I pointed out. I have the control voltage running through a very large capacitor back to ground. And that's basically keeping that from going out all the way. It doesn't go all the way to 0 or all the way out to 5 volts. It doesn't go all the way to 0 or all the way to 5 volts, and that's what that control voltage is doing. Another thing, putting it together like this, I figured that out and understood that. And then kind of talked about that, and then the sine wave, well, it looks more like a sawtooth here. We can see it kind of comes up, has that nice smooth curve there. So the curve here, and then the curve down here, those are kind of the same. Those are affected by the same piece. So by changing, so this resistor and capacitor, again, that's just adjusting the frequency. But by changing this capacitor and the size of these resistors, it adjusts the level of that, how smooth that curve is. Oh, pointed at the wrong thing. The capacitors and those resistors adjust this curve. So right now I have fairly small values, so it's a very sharp curve. But as those values got larger, that curve, that corner there kind of smoothed out. And the corresponding one down here. And for the front corner here, changing the value of the inductor and this capacitor, which is also involved in the frequency, changing those affects how smooth this corner here is. So obviously the state where I left it to shoot the video isn't the smoothest sine curve or and the triangle waves there in the middle or something, but putting it together like this, I developed a much better understanding of what each piece is doing and how to develop these waves should I need them. That's what I consider doing it myself, and I just wanted to express that point. I guess there's different ways to do it yourself. And one of the things I find the most fun about electronics is sitting down and experimenting, have a piece of paper and write down everything I change on the circuit and what happens when I change it, and develop an understanding of what's going on, not just solder some pieces in place and go with it and have absolutely no idea. But I just wanted to kind of express that. This is more along the lines of what I consider to do it myself, though obviously I'm shooting the video now because this probably isn't going any further. If I needed a function generator, I'd just buy one. But I wanted to express the thought here about doing it myself.